Greetings. This is Peg Brady at NOAA Fisheries in Silver Spring, Maryland. This is the third year of our ecosystem-based management, ecosystem-based fisheries management seminar series. And today we have Dr. Sarah Gaichas from our presenting this presentation from her laboratory at the Northeast Fisheries Science Center in Woods Hole, Massachusetts. Sarah's been as a research fishery biologist there, and the title of her presentation today is There Is No I in EAFM, Adapting Integrated Ecosystem Assessment for the Mid-Atlantic Fisheries Management Council. And I want to thank Sarah and her team for providing this presentation today. This is a monthly series, as a reminder to the folks who have joined us in the past. This is on the second Wednesday of each month. And our next presentation is on February 12th by Michael Abbey from our International Fisheries Office. And so I'm going to turn it over to Sarah and thank her, and she will hopefully introduce her colleagues there. There's on the title slide. And thanks again, Sarah.
Thanks very much, Peg. I'm hoping you guys can hear me. I'll just test that one more time.
Yes, it's coming through nicely.
Excellent. Okay, thanks so much. And thank you, Peg, for inviting us. So first, yes, I would like to acknowledge my co-authors on this talk. Garrett DePiper, who's here at the Northeast Fisheries Science Center in the Social Sciences branch. Brandon Muffley, who is staff for the Mid-Atlantic Fishery Management Council. Rich Seagraves, who was staff for the Mid-Atlantic Fishery Management Council and is now retired and hopefully fishing in Florida somewhere and not listening to this talk. And Sean Lucy, who is also my colleague here at the Northeast Fisheries Science Center. And so just to cut right to the chase, the most important thing is to give you my conclusions on the very first slide. So if you have to leave or you get bored or something, at least you've got the main message. So I think what we're presenting here today is really a success story for integrated ecosystem assessment, but it's a story that's in progress. So I'm going to try and go over what the council has been doing, what we at the Science Center have been doing to support them, to achieve their objectives for ecosystem approaches to fishery management. And I think really what it comes down to is that, first of all, they had diverse stakeholders who agreed that an ecosystem approach was necessary in the beginning, and that they've been developing and implementing their ecosystem approach in collaboration between managers, stakeholders, and scientists. So this really is a collaboration, and I think that's why it's been as successful as it has so far, and so hence the name, a little play on words there with There Is No I in team. So the outline of the talk today is, first, I'm going to give you some background on how the council, I'll just call them the council from now on, developed their ecosystem approach. Then I'll speak a little bit about how at the Science Center we work to tailor our ecosystem reporting to make it more useful for fishery managers. From there, we'll talk about the Mid-Atlantic risk assessment that they did as part of their ecosystem approach. And after that, I'll talk a bit about the conceptual modeling that's just been done, hot off the presses, which is leading the council towards a management strategy evaluation, or MSE. And then finally, we'll talk a little bit about how we've produced some of this stuff using open source data and methods. And so over here on the right-hand side of our screen, we have the integrated ecosystem assessment loop that I'm sure many of you have seen, especially if you've been following this seminar series, where essentially it's a process where there's, first of all, the goals and targets are defined, then indicators are developed, the ecosystem is assessed, there's analyses of uncertainty and risk, and there's strategy evaluation. And then there's this inner loop of implementation, basically, where you continue to monitor and you continue to evaluate and you can keep feeding back into the loop. And so this is a really useful framework to think about how one might implement an ecosystem approach. And also the important thing here is you don't need to do all of these things in order, and that some of them can feed back in with different arrows here and be really useful used in sort of a slightly different context within the loop. And so the flexibility of this process, I think, is something that we should all be thinking about as we move forward with implementing ecosystem approaches as well, because the flexibility is what allowed the Mid-Atlantic Council to really adapt it to their needs and to be able to make progress on what they wanted to do. So some brief background on fishery management in the U.S., which I'm sure almost no one on this in this audience needs, but just in case, What we have are 8 regional fishery management councils, and they are making the fishery management plans that are for all the stocks within their jurisdictions. And so basically the idea here is in the U.S., everybody's governed by the same law, but each council tailors management to their regional stakeholder needs. And so I will be talking about the Mid-Atlantic Council over here in dark blue, but on this coast we also have the New England Fishery Management Council and the South Atlantic Fishery Management Council, and over here the Gulf of Mexico Council, there's the Caribbean Council, there's also Western Pacific, Pacific, and North Pacific councils. And another note that I want to say right now while I'm thinking about it is that the Mid-Atlantic Council was really looking at a lot what the other councils were doing with respect to developing ecosystem approaches. And I think they were very interested in what the Pacific Council had been doing at the time. And I'd also like to add that many of our colleagues in the Pacific and the North Pacific have been doing a lot of good IEA work, and I think we're sharing that and benefiting from that all across the country here. So I want to give a nod to them as well. So those are the Fishery Management Councils, specifically the Mid-Atlantic Fishery Management Council now outlined here, and I've grabbed these images off their website. These are the states that are within their jurisdiction, but they do manage stocks throughout the stocks range. So you can see here, these are each of their fishery management plans that we have listed. So they have a summer flounder, scup, and black sea bass plan. That's a multi-species plan. They have a plan for spiny dogfish, but that's joint jurisdiction with the New England Fishery Management Council. There's a plan for a lot of what might be considered commercial forage species, so squid, butterfish, Atlantic mackerel. There's a single species plan for bluefish. There's an invertebrate plan for surf clams and ocean quahogs, and a tilefish plan. So this is a fairly diverse set of plans of different species, and the plans are set up more around fisheries than they necessarily are set up around ecological interactions. And I think that's true of just about every fishery management council in the country, except for maybe Western Pacific that's rearranged their plans around different regions. But anyway, these are their plans, and they continue to work with these fishery management plans. But in this talk, you'll see how they're trying to integrate ecosystem considerations throughout them. So why did the council decide to take an ecosystem approach? I saw Rich Seagraves give several talks on this, and I think the line that really struck me the most was basically they spent the 2000s rebuilding their stocks, like many councils across the country, and they came to the end of the decade, and basically, as Rich said, we rebuilt all the stocks. Why is everyone still pissed off? And the answer is that, maybe just rebuilding the stocks doesn't address every single objective that a council might have for fishery management. So what the council did in 2011 is they embarked on what they called a visioning plan. And all of this happened, this is all council driven. I want to emphasize that I may be the speaker here, but all of this was driven by the Mid-Atlantic Council, and I'm just telling you what they did. This happened before I even worked on this coast. So what they did was they went and they asked all their stakeholders. They wanted to know, what is it about management that needs to be improved? And they left the questions wide open, and there's a whole report linked at the bottom of the slide that you can find out more information. But basically, they did have meetings and focus groups all up and down the coast. You can see here in this map. They had a lot of survey responses, over 1,000, a lot of them linked to specific fisheries. They had different letters come in. And so they developed this whole report based on the questions that they were asking their stakeholders. And the interesting thing was there were a lot of common themes among their stakeholder groups, and there are very diverse stakeholders in the Mid-Atlantic. So there's recreational fishermen, there's commercial fishermen, there's each different state has different interests, the fisheries differ geographically, there's environmental groups, there's a whole bunch of different people interested in fishery management here, but there were very common themes across these groups. One was a lack of confidence in the data underlying the management decisions. Another, which is possibly related, is that stakeholders were not as involved in the council process as they could be or should be. Also, that different jurisdictions and regulations were confusing to people. They resulted in complexity and sometimes inconsistency. And so also related, there's a need for increased transparency and communications in fishery management. And importantly for us, the dynamics of the ecosystem and food web should be considered to a greater extent in fisheries management decisions. This was across all stakeholder groups. Stakeholders felt they were not adequately represented on the council, and also that pollution was negatively affecting the health of fish stocks. Again, more of an ecosystem consideration. So all of this is summarized in the report. So after finding this out, what is it that people actually want out of management, the council proceeded to use the visioning project as a basis for a strategic plan. There were many objectives in the strategic plan, and I would encourage you to look at them if you're interested in how they move forward with this. But one of them specifically was to develop this non-regulatory umbrella document, so something that would guide council policy with respect to ecosystem considerations. So they're calling this a policy guidance document, not necessarily a fishery ecosystem plan, but something that they could refer back to. And how did they develop this? From the visioning project, there were categories of interest to people. So forage fish, species interactions, social and economic issues, climate and habitat were all identified by stakeholders. So what the council did was they held workshops on each of these things, understanding that they're related to each other, but trying to sort of bite off a piece of the ecosystem issues and look more in depth at that. So each of these workshops was held at a council meeting, and they generally lasted a full day. This was a major investment by the council to do these workshops, starting with forage fish in, I believe, 2013 and going all the way through a habitat workshop in maybe 2015. And so what they did was they brought in experts in the field, and they had presentations, and then there were discussions with the council. And out of these workshops, white papers were developed on each of these topics. And the white papers kind of morphed based on what was in the workshops. So these were all public workshops. They had a lot of feedback from stakeholders and council members, as well as other management organizations. And the white papers formed the basis for what eventually became the guidance document. So you'll notice here that social and economic considerations started as a separate thing, but what happened was it became obvious you couldn't talk about any of these things without also talking about social and economic considerations. So they wound up being integrated throughout each of these white papers. And so what wound up coming out of all of this in 2016 was actually the EAFM policy guidance document, and it's linked here on this slide, and it's summarized here as a process. So the framework that the council is using for EAFM, if you look at this, you will see a lot of the components that are in integrated ecosystem assessment from that loop on the first slide. So the process basically is to prioritize what the council wants to do among all the possible issues, to refine what they want to do about the priority issues, to analyze those issues and management strategies related to them, to implement, monitor, and go back through and prioritize again, refine again, etc. And so this is the general strategy, and the tools that the council decided to use are for prioritizing a risk assessment. So one good way to prioritize things is you say, what is the highest risk thing that I'm facing here, right? And so that's the prioritization step. Then the conceptual modeling step here is how you refine things. So once you've identified your priority, what is the key question and what information is necessary? And this is the stage at which you would draw the connections between the issues of importance to the question. And so conceptual modeling, again, I have to say a lot of really good work on this was pioneered in the West Coast, and we followed a lot of our colleagues' lead on that, and I think we found conceptual modeling to be a really helpful tool to basically act as a checklist and figure out, have you included all of the important interactions that are relevant to this question? This is the step that we don't usually get to do when we look at things on a case-by-case or species-by-species or issue-by-issue basis. So it's a very important step. Once that's refined, then you do an analysis. So a management strategy evaluation, which I think a lot of folks are more and more familiar with, is a way of saying, in a computer, can we test different management strategies that might address our objectives, achieve our objectives, while dealing with the uncertainty in the interactions and everything that's been identified up here before from the risk assessment and the conceptual modeling. And so you ask which of your strategies perform best. Then if you like one, you implement it, monitor it, and go back through the loop. So this is all described in this paper that's linked down here. And again, very much based on the integrated ecosystem assessment approach. So what we found was helpful, it was mainly Rich Seagraves and Garrett Piper and I working on this at the time, was to show examples of how to use the framework, so that this is especially helpful in a stakeholder and management context at a council meeting, where instead of like showing people this flow chart of how you do things, and that works pretty well for scientists, but then it's kind of not that interesting to people who are actually trying to do the management. So what we came up with, Rich and I, was a sort of mock-up of what a risk assessment might look like, very simply, and show, okay, if you had your summer flounder, scup, and black sea bass FMP here, and you looked across all of these different issues, and you don't need to worry about what these are right now, I'll show you the full example later. you might say, hey, there's a lot of red indicating high risk for this fishery management plan. So you might decide to choose that. And then in your next step, you would map out the key interactions. So here's summer flounder, scup, and black sea bass, which you're unlikely to be able to read on this slide, but don't worry about it. It's just an example. This isn't the real conceptual model. And then you would start drawing links to the different things you were concerned about, especially if they were things that tended to be high-risk things. And you could use this conceptual model, again, as a checklist to start to build your more quantitative models for management strategy evaluation. So we brought these things to the council, and the council said, yeah, that might be a good idea. Maybe we'll give this a try. And so the first step was risk assessment in the process. And so starting with risk assessment isn't necessarily how it works in the IEA loop that I showed you at the beginning, but risk assessment is an incredibly familiar tool to folks across many industries, as well as in science and business. So risk assessment is a nice way to get into something like this decision-making process using methods that people understand. However, you have to make sure that you're actually framing the questions correctly and assessing the risks correctly. So in my cartoon here, provided by XKCD, one of my favorite comics, and you guys have probably seen these before if I've given presentations before, but so we got the first guy who hears the lightning crack and says, hey, we should get inside. And the second guy says, no, I've got a statistic on this. I've done some science, and really only 45 Americans a year die by lightning, so our chances are only 1 in 7 million. So we're fine. Okay, so the first guy was actually applying conditional probability. He framed the question correctly. Given that I have seen lightning, what are my chances of getting struck by lightning? The second guy might have known his statistics, but he was not framing the question correctly, and so of course the annual death rate among people who know that statistic is 1 in 6. So we want to avoid things like that, and so setting up the risk assessment is probably one of the most important things, and one thing that was done, again, collaboratively with the council. So once we had given the example and they said, yes, we want to do this, we used an iterative process to work through how we were going to set the thing up. And especially definitions were very important to this process. So we really needed to clarify all of the things we were talking about. So we started calling the things we were measuring risk elements, and why we were measuring them risk definitions. The thing we use to measure it is an indicator. This is where the ecosystem indicators might come in. And what the actual risk is the ranking criteria. So again, this was an iterative process. We would usually start with an example between council staff and some of us doing the scientific work, bring it to the council and the committees, have them discuss, clarify, and a lot of times they came up with much better clarifications of what they wanted, having seen an example. And so this worked really well for us. And the full process is described in this risk assessment paper, but I'll just show you how we did this in a moment. So indicators are an important part of this, right? But the setup here is almost more important to understand what it is you're talking about. Like I said, the framing. And so the council actually wound up defining a lot of risk elements. In that little example I showed you, I think Rich and I had, or mostly Rich, had come up with a few things we would look at, and they wound up being mostly this list of ecological risk elements. So things like assessment performance, the fishery status in terms of fishing mortality and biomass, these second two here, this is what we do all the time in stock assessment, looking at the food web aspects, looking at ecosystem productivity, climate, distribution shifts, estuarine habitat, etc. These are all things that we thought of as ecological, and the council came back to us and said, that's great, but actually there's a whole lot of economic and social things that we're very concerned about. And so they came up with a lot more risk elements and identified them here. And so what we have are economic risk elements, looking at things like commercial revenue, angler days and trips, commercial fishery resilience, several different aspects of that. And so the definition is, why are we looking at this, and the indicators that we might have here to look at it. And again, for social indicators, things like fleet resilience and other social cultural indicators that had already been in development were used. And food production is an important objective as well, so commercial and recreational food production. And there was a whole set of management indicators that, of course, I think as scientists we wouldn't necessarily think of, but are really very relevant to the council and to the council staff. So things like management control, like the risk of not achieving OY because you can't actually control the catch. for one reason or another. Things like interactions with other fisheries or other species or protected species, things like other ocean uses, such as, for instance, in our area right now, wind energy, regulatory complexity, as was raised by the stakeholders in the visioning project, things like discards, and for sure allocation between fishery sectors and across states. And so there are all these elements that we wouldn't have thought of as scientists that were super important to the council, and they were integrated in this process because of just designing the risk assessment. So now where will we ever get the risk assessment indicators from? Well, this is actually the easy part for us as scientists. We consult our mountain. No, we have ecosystem reports already. So a lot of us are doing ecosystem reporting. And I think we showed one of these to the Mid-Atlantic Council's Scientific and Statistical Committee in late 2016 to say, hey, what do you think of this? And so what, again, another quote that really stuck in my mind was John Borman, the chair of the SSC, said, yeah, that's nice, but so what? What am I supposed to do with this? And I think we had presented this in a format that's fairly standard for ecosystem reports. You know, you kind of start with climate and you work your way through and you say what all these big indicators are. And it turned out that that is interesting to scientists and, again, perhaps not immediately obvious how it's useful to managers. And so what we did was we did a major redesign of our ecosystem reporting. And the things that we really wanted to do are listed here. We wanted a clear linkage of our indicators with management objectives, a synthesis across the indicators so you can get the big picture of what's going on. A simple thing that we did, but one that turned out to be very effective, was to place the objectives related to human well-being first in the report instead of last. Keep the report short, always important when people have a lot to read, and also emphasize reproducibility for the report so that we could produce them and the council could receive them on a regular basis. So the revised reporting basically involved a structure, which was a synthetic overview, a human dimension section, protected species section, fish and invertebrates, and then habitat quality and ecosystem productivity. And what we did was we aligned the indicators here with these categories of objectives. And the objectives basically are derived from the Magnuson Act. So we are, the definition of optimum yield has to do with providing on a continuing basis for the nation optimal seafood production, recreational opportunities, things like profits and fishery stability are also identified in a lot of the implementing legislation, social and cultural benefits, and of course biomass and productivity are things we look at already. Trophic structure and habitat are ecosystem attributes that are quite important. And so we tried to make it very clear how indicators link to objectives. And we also standardized our indicator visualization. And I think this is something a lot of regions are doing right now. So this isn't new news, but it's something that we did that worked for us, was to basically simplify things so that we would have our time series and they were always year versus whatever the indicator was. And we chose to highlight whether something was significant or not by having an orange line on the plot if it was increasing or a purple line on the plot if it was decreasing. And so in this way, you could get a quick look at how things worked. And I'll show you an example of this in a moment. But the other thing that was important is that the spatial scales were already Mid-Atlantic specific in our reporting. So we could do the state of the ecosystem report for the Mid-Atlantic based on the Mid-Atlantic Bight Ecosystem Production Unit, which had been defined previously. And the New England report looks at the Gulf of Maine and Georges Bank Ecosystem Production Units. So here's an example of how the risk assessment was linked to the ecosystem indicators in the existing reports. So what I'm showing right here is the indicators, total revenue, and this indicator is linked directly to profits, right? So in the risk assessment, the element is defined what level it's applied at. So for the whole ecosystem, we're looking at revenue, which serves as a proxy for profits, right? Here's the indicator. And what it's showing you, that the black is the total revenue for all species groups, and the orange line is that it's not linear, but it is generally increasing over time. The red line is the Mid-Atlantic managed species commercial revenue, and the purple line shows that that's generally decreasing over time. This is about a 30-plus year time span. The Bennett indicator was looking at price versus volume, so we had these mixed indicators, but it's an example of one of the indicators from the report. And the criteria come in here defined by the council. What do we want to call low versus moderate versus high risk? So a risk level of low was defined as no trend and low variability in revenue, whereas a risk of high was considered to be a significant recent decrease in revenue, okay? And so based on discussions with the council, this is how we've chosen to analyze the indicators in the ecosystem report. So we look for significance, and this tells us what the risk should be. This was ranked moderate to high risk because there is this significant long-term revenue decrease for the mid-Atlantic managed species. So that's one example of a single indicator and how it was used in the risk assessment. We also used a risk element that would have multiple indicators in it. So for instance, system productivity used a combination of 4 different ecosystem productivity trends that looked at both low trophic level and fish level information. So it's primary production, zooplankton abundance, fish condition, and fish recruitment. And the risk level now is defined on if there's no trends in any of these, we're going to call that low risk because things are just kind of bouncing along without any real trend. We're going to call high risk a decreasing trend in productivity for all measures. So that means everything's going down, and that's probably a bad sign, even if we don't know the mechanisms necessarily. And somewhere in between are these different trends. And so what we did was we looked at all 4 trends. So here is the monthly primary production, and you can see that there are some increasing trends in some seasons, but overall there isn't a general trend necessarily. However, zooplankton abundance, several of the main species do have these decreasing trends over time. We've pointed out a lot before the fish condition. These are the mid-Atlantic managed species, had basically dark is high condition, so fat fish for their length, and light colors are thinner fish for their length. And so there was this somewhat general decrease in condition in the early 2000s, and some species have recovered since then. So no real trend there, but possibly some interesting patterns. And then finally, this is productivity, basically a small fish per large fish biomass indicator from the surveys that's intended to be complementary to stock assessments, which is showing what might be a decline in productivity, but not necessarily significant across all species. So again, this was ranked low to moderate risk due to the long-term trends in zooplankton abundance. Not all of the risk indicators were from directly from time series indicators. So there are a lot of risk assessments out there already, and one of the really good ones that had just been published was by a lot of folks here at the center and at headquarters, a vulnerability assessment, a climate vulnerability assessment for all of our species. And this is being done or has been done across many regions in the U.S. And this is an incredibly valuable resource for doing something like risk assessment in the ecosystem context, because here we have all of our species ranked for vulnerability. So really all we had to do was take the rankings from the Hair-et-al risk assessment and align them with risk levels for the council. And so low risk was things with low climate vulnerability, and high risks was all these guys up here in red with very high climate vulnerability rankings. And so that was at the species level. And again, that's not a time series, but that's another analysis that you can incorporate. So it doesn't all have to be done from scratch. And so this is the set of results. So here are all the management elements that we showed before, and here are all of the fisheries, commercial and recreational is what C and R mean. And I'm not going to go through blow by blow what all of these are, but you can get a quick look and see that maybe regulatory complexity and allocation are some issues across many species in the mid-Atlantic. And so this is kind of a handy little cheat sheet, as one of the council's members said, of what's going on for each species. When you look at the species level elements that are ecological elements, so here's assessment, data quality, basically F&B status, food web, etc. Here's climate and distribution shift. These come directly from that climate vulnerability analysis. And so you see which species, that many mid-Atlantic species have a fairly high risk of distribution shift, but only some of them are highly sensitive to climate. And then here are the ecosystem level risk elements. So the commercial revenue here with moderate to high risk, for example. And so you can start to see across all of the species and at the ecosystem level where your risks are. And so this, I think the Mid-Atlantic Council was fairly pleased with this, and they've asked every year that when we do our ecosystem status report that we update their risk assessment with those indicators so that they can get an update of what all these conditions look like. So this slide I just showed you is actually the 2019 update of the 2018 risk assessment. A few things did change in here, not too many, but summer flounder, for instance, based on a new assessment, went from a higher risk status to a lower risk status due to the new assessment. So that type of information can be incorporated right away. But the next step then is conceptual modeling. And so what the council did was they had looked through and they had actually selected summer flounder as one of their high-risk fisheries based on all of those indicators, management and ecosystem and species level. And they convened in 2019 a working group of different experts to try to put together a conceptual model and also identify data sets and do sort of a gap analysis for each element of the conceptual model, and also come up with a list of questions that the council might want to pursue. And so this is sort of an example of learning by doing. The council said, well, we have this framework, but we've never really used it before. So why don't you show us in general what we might be able to do here? And so that is what the working group did. The final conceptual model and all that supporting information was just presented about a month ago at the December 2019 council meeting. And the council did decide to proceed with management strategy evaluation, which is the next step, using this information as a basis. And the topic that they selected was looking at recreational fishery discards in the summer flounder fishery in the EAFM context. And so what I'm going to show you next is an image of the conceptual model that was built. Let's see, did the council chair call this, I can't remember the exact phrase he said, but he said don't look at it too long because you might get kind of sucked into the vortex. But what we tried to do was make this a little more digestible to people by doing an interactive presentation. So what you're seeing around the edge of this are all of the elements, a lot of the risk elements from the risk assessment, but also other elements that are important to summer flounder as determined by the working group. And what you can do here is, because the council selected discards as the thing that they're most interested in and how to, reduce those and improve value to the recreational fisheries and also the status of the stock and the fishery objectives, you can highlight discards in this and you can see the things that connect to them. So these wider bands that are going towards discards are things that affect discards. So for instance, you can see that you have a band coming in from fluke distributional shift, which I apologize is cut off at the bottom of your slide. So you can say, well, distribution shifts affect discards. What affects distribution shifts? Now I can go here and highlight distributional shifts, and I can see that when I do that, things like temperature up at the top of the plot, oceanographic transport, offshore habitat, food web changes, estuarine habitat, all of these things are affecting distributional shifts. So again, this is intended as a qualitative tool that will help you have a checklist of the interactions that you need to address when addressing discards. You don't need to do all of them necessarily, but what this provides is a way to figure out what the most important interactions are in your system and make sure that those interactions are included in your quantitative analysis. Now, the associated thing that came with this, of course, was the list of different data sets and other information that's available for each of these links. There's more for some than for others, but summer flounder is a very data-rich species and fishery in this region, and so there should be a lot to work with. And so the next step will be coming up with a more quantitative analysis based on this. So really what that brings us to is, again, this is a work in progress. We haven't done the MSE yet. It was just decided about a month ago that it's going to be done. And so we'll work through the more quantitative analyses in the coming year plus. But I think what we have learned from this process so far is that IEA is a really valuable framework for implementation of ecosystem approaches, and that's because it's flexible. Okay, you don't have to do it all in the same order. You don't have to use all the same steps, but it gives you a process, and councils need processes to work through. So I think the rapid progress that the Mid-Atlantic Council is seeing in their EAFM implementation is resulting from a collaboration, and the way they've set this up from the very beginning is that this is an open process. It's a collaboration between the managers, the stakeholders, and the scientists. And this, to me, is one of the reasons this is really working, and I think it's probably going to be essential to any successful EAFM or EBFM process. We also learned that ecosystem indicators and reporting can be tailored to specific regional objectives. So we had our general report, but when we went through for the risk assessment, we tailored it a bit more. We got a few more categories that the council finds useful. And so overall, the product is improved for them. That we also learned, and I think probably everyone who's done risk assessment understands this, it's a really useful tool. It's quick, fairly quick. It's familiar to a lot of people. You can scale it a lot of different ways, and it's transparent. So that makes it a really good way to implement EAFM within this operational fishery context. And I think the way the council has set up their EAFM process in particular allows them to focus in on certain issues that have the higher risks, and then they can work from those. I think one of the concerns expressed early on in the council meetings and in the workshops was EAFM is just too much. There's too much stuff there. There's a lot going on. How can anyone sort this out? Their process allows them to sort it out. It identifies the high-risk things, and it allows them to deal with them one by one, but it allows them to keep abreast of if any of those risk factors are changing. And finally, I think we also learned, as other people who have learned use conceptual modeling have learned, that it's a really useful process as well. It's simple, it's also fairly quick, but it does allow you to link up these key factors for the high-risk fisheries, and it's a really good scoping tool for the more detailed analysis that needs to happen under management strategy evaluation. It gives you a nice checklist so you can make sure you didn't leave anything out. As a footnote, we have been developing all of this in sort of an open data type of context. So we want to have better reproducibility. We want people to understand the data provenance. And this, again, may be more for the scientists in the audience than the managers in the audience. But in particular, when we present to scientific and statistical committees, they're much more interested in the methods and where did this come from, and also, can I get that data? And so what we've tried to develop here, and thanks to some really excellent data analysts that we have here at the center, Sean Hardison last year and Kim Bastille this year, who have been working very hard to make our process completely open and accessible on GitHub. And so if anyone's interested in that, I'm happy to provide details. But basically, not just the data, but also the documentation of the data is all available. So you should be able to get all the way back down to even the code that people use to develop their indicators. For even more details, this is an HTML presentation, and all of these are links. So you can follow these links to your heart's content and see all of these different products that were described here. And also all of the presentations are available on this website if you would like to see them. And I really must thank all the contributors to the State of the Ecosystem reports. We had at least 38 from 8 different institutions, all these folks on this slide, and also more who are contributing each year. So I really want to thank those folks, because providing that indicator data is what makes all of this possible to be able to provide these products to the council so that they can do their management. And with that, I'll say thank you and ask if there's any questions. Our contact information is there. I haven't given you Rich Seagraves' personal email while he's retired, but I'm sure if you want to contact him, the council can hook you up, but the rest of us are there. So thank you very much. I will stop there.
Thank you, Sarah. That was excellent. Appreciate it. Just in terms of questions, we have a number of people online. So if you have a question for Sarah and her team, you can put that in to the chat box there. And then we also have a number of folks here in Silver Spring. So if there are any questions here among the folks in the audience for Sarah. Okay, no one? And let's check online here. Do you have any? Okay, we have a question here for you, Sarah, online.
The question is from Shannon Martin. What application software was used to produce the circular conceptual model?
Yes, so that is, it's all done in R. I would be happy to share the code. Garrett DePiper developed the circular model first in one R package. And then when we decided we wanted it to be interactive, we re-implemented it in another R package. So this is all done within R with publicly available packages, and I'd be happy to send the code. Does that help?
Yes, that's great. We will forward on Shannon's contact information so you can help her with that.
I can send the whole GitHub repository and she can see how it's all done.
And just as a reminder, folks, all these seminars are archived thanks to the NOAA library. So you can see the past presentations, and what we'll have up are all those links that Sarah had provided, so folks can go into the presentation as well as the background links. Any other questions coming online? Oh, there's looks like a couple coming in now.
Okay. Kim Ainsworth, how do you resolve conflicting indicators like short-lived species are good for production catch revenue but bad for system maturity? Biodiversity would similarly be in conflict with revenue. So it seems you need a multivariate approach and agreed upon weights for these priorities.
Yeah, thank you, Cam. That's an excellent question. And right now, the way the council is treating all of these risk elements in the risk assessment is they're essentially equally weighted. So basically, by doing a quick visual on these tables that are up here on the screen, you're saying, where's all the red? So we presented multiple methods that they could possibly use to integrate these things, and some of those would involve weighting schemes, and they could get very detailed. And I think when we presented the different options, the one the council felt was most appealing to them and useful was basically the most transparent one of equal weighting and saying, okay, we've said each of our risk elements is important to us. We haven't gone back and said one's more important than the other necessarily, but just overall, when you look at them, the highest risk can be gotten by just counting up the number of red cells, basically. Now, obviously, when you go back into the more detailed analysis, it becomes much more important to clarify the difference between, say, a red for regulatory complexity and a red for discards, for instance. And so that's the kind of thing that's going to happen in the quantitative analysis. But by doing that after you've focused on your high priority species or issue or fishery, you've at least avoided having to compare apples and oranges, like a red for summer flounder versus a red for squid, for instance. So I'm not saying that would work for everybody, but I think that's how it's working for the Mid-Atlantic Council right now. What you've presented is a challenge, and I think they're dealing with it by sort of going through it stepwise instead of trying to have weightings for every single species and every single thing at the very high level. But if I have said something wrong, hopefully one of my colleagues from the council or Garrett can correct that.
Okay, great. Thank you. We do have a couple more questions. Hassan Mustafid would like to know if all of this data used in the analysis is available on ERDAP.
It is supposed to be and was for a while and may even be now. We're having a little bit of trouble with our ERDAP server. That's why I'm hedging a little bit. But we intend and plan to have all the data available on ERDAP. And I will let you know it may be there right now, or it may be that you can only get it through the EcoData R package. But one way or the other, we can get you the information. The intention is to have it all on ERDAP eventually, once we iron out some basically server technical issues.
Great, thank you. Wendy Morrison was wondering, how helpful do you think the visioning exercise at the beginning of the process was? Would you be where you are now without that step?
I think that is the most important thing that was done, honestly. I mean, and that, that was all the council. That was, I think we would not be where we were if they had not done that step, because I think that's what helped them get to what are their goals and objectives. Why do they even want to do this? It's kind of a lot. I'm going all the way back to the slide with this. It's a lot to figure out what you want your ecosystem approach to look like. There's so many options. There isn't a recipe. And so because they asked people what they wanted to see in management in general, and because everybody came back saying, we want to look at ecosystem information, that we want a more transparent process, we want to be able to understand this complexity, that basically allows them to move in this direction in a way that I think you can go back and you can say, if someone says, why are we doing this? You can say, well, because this addresses all of the issues that the stakeholders actually brought up. So it's not that, someone just decided this was going to be interesting or fun. It's really that they needed this. And and asking the stakeholders first, I think, is the best way to figure out what direction to go in. If they had said something a little bit different, I think the EAFM approach would look different, and that would be fine because it would be addressing the questions that they had. So I think it was absolutely essential.
We have one question here in Silver Spring from Stephanie Oakes.
Hey, Sarah. As a follow-on to Wendy's question, is there any idea of when that visioning process would need to be repeated so that it remains current to the stakeholders' current ideas and needs?
I think that's more a question for the council, so hopefully they will correct me if I answer this incorrectly. But their strategic plan was, I believe, a 4 or 5 year plan. And so they did just go through, or they are currently going through a process of updating that right now. And they did ask for feedback from a lot of people involved with the council. I know as an SSC member, I saw the request for feedback. So they are updating it, but I would ask the council directly for more information on that because I received some of the questions, but I'm not involved in that process.
Sarah, we have a few more coming in online. So here we go, Katie.
Okay, from Roger Griffiths. Thanks for the great presentation. It seems like forecasts and projections of future ocean conditions, shifts in distributions, et cetera, are getting more robust and might be useful input to the risk analysis, conceptual models, et cetera. How do you see that sort of stuff being incorporated into the indicators and process?
Yeah, that's an excellent question. I think for me, where you would start using that kind of quantitative information, well, first of all, those sorts of projections were used in the 2016 vulnerability assessment. So they did do some basic projections to help with the assessment of the exposure part. So there's exposure and sensitivity in the climate vulnerability analysis for each of the species. So there's some of that is integrated in there, but I think Roger's absolutely right. They're getting better, and I think the step where a lot of this would come in, so the conceptual model would tell you basically what things, which aspects of, say, something about the climate are most important to the species. So in the summer flounder model, you had temperature and you had oceanographic transport, for instance, linking up to distribution shifts. And then I think maybe in the management strategy evaluation, that's where you could possibly build operating models that would be able to accommodate climate projections if those things were considered to be some of the most important uncertainties or the most important drivers of the species and the issues. And so for discards, depending on the time horizon that you were looking at, I'm not so sure that you would necessarily want to use that for this particular MSE. But if you were looking at more long-term things like the distribution and how that's supposed to be over a much longer time period, it's possible you would want to integrate that. So I think this framework would certainly accommodate using that kind of information. And just off the top of my head, I would be using that in the MSE portion so that you would be using the right pieces. Hope that helps.
Yes, thank you. From Paula Keener, thank you for this information. Have you worked with anyone on the SAFMC EBM advisory panel regarding any of this?
I'm not sure who that is, so probably not.
Sorry, that is the South Atlantic Fisheries Management.
Okay. You know, there was a South Atlantic representative at the council meeting in December, and she seemed very interested in the conceptual model work and the presentation that we had there. And so, you know, we would be happy to show them this information and anything that would be helpful to them. I'd be happy to contribute. But so far, not directly, no.
Okay, thanks. We do have a couple more. From Gonzalo Banda, do you envision a simplified approach could be developed for areas with fisheries and ecosystems limited data?
Yeah, I think a lot of aspects of the risk assessment don't necessarily require time series of data. You could have snapshots of conditions. A risk assessment is a very flexible tool, and you could design qualitative risk assessments. There's a lot of examples of those. So I think you could do the risk assessment step in a data limited situation. you would just, it would look, the framework of the risk assessment would be different and the methods would be different, but there's a lot of examples of those, and they are still really useful, I think, for doing the type of thing that the Mid-Atlantic Council is doing. Similarly, conceptual models are qualitative models and do not require a huge amount of data to build them. They require some expert knowledge, and I think you could build conceptual models that were useful even in a data-limited situation. When you get to management strategy evaluation, I think that's where you can build models, and you could probably have general models. Lacking data to condition the models would increase the uncertainty, I think, in what you were going to get out of the MSE, but it doesn't mean you can't do it, certainly. So I think the framework itself is very amenable to it. You would be altering the methods to use more of the data-limited methods that are available.
Okay, great. One last question. Are there plans to do this in the New England Council that you're aware of?
The New England Council did ask, when we did the risk assessment, I was requested to provide a similar document for New England, and we basically did the same risk elements that have been selected by the Mid-Atlantic Council and put New England data for it as an example, but with the caveat that I think the council would actually need to go through and redefine risk elements that are most relevant to their region. So for instance, I wouldn't expect that all of the issues and concerns in the Mid-Atlantic are exactly the same in New England. So I think they would benefit quite a bit if they chose to do this, to go through and actually basically reevaluate all those risk elements, and then there might be different indicators. But we did show them an example a year ago or something like that. I will say that their ecosystem approach is a bit different, and so they are working towards, I believe, a management strategy evaluation, but I'm less involved with that process right now. They do have an example fishery ecosystem plan that they've been working on, so a lot of the same information is available for New England. And I think they are looking at more of a systemic kind of management plan rather than an EAFM approach that leaves their FMPs in place. But again, I'm less familiar with that.
Okay, thanks, Sarah. We do have some comments from Braden Muffley. Sarah was right. Through the strategic planning process, the council just conducted its second strategic plan from 2020 to 2024 with extensive stakeholder feedback and engagement. Goals, objectives, and strategies to implement the EAFM guidance document are included within the new strategic plan. And also, they are presenting this work, the Gulf Coast Ecosystem Technical Committee, in a couple of months as they develop and the fishery ecosystem plan. And we do have one last question from Joseph Warren. Have any future biological research priorities emerged during this ecosystem approach work?
I think the council was also just redoing their priorities, and thank you, Brandon, so much for that clarification. That's super helpful. You might even also be able to clarify this one. So the council did just go back through research priorities. I think as part of the conceptual modeling and gap analysis, we did identify where information might be missing or less available for the particular summer flounder fishery and risks there. And I think as part of developing models for management strategy evaluation, we may be finding out more about where some of those gaps are and possibly developing more priorities for further research. But I don't know if Brandon wants to comment further on that. He's typing furiously, probably.
Okay, well, we've reached the end of our questions here, Sarah, here in the room and online. Thanks to everyone who participated and joined today. And thanks to Sarah and her colleagues. Excellent presentation, great information. Again, if you need more information, look for us on the NOAA library site. And also you can register and share this information with other colleagues. There's Sarah's email address, and Garrett and Brendan and Sean's. And so there you have it. Thanks again. Please join us February 12th for our next monthly seminar by Michael Abbey. So thanks everyone, and Happy New Year to everyone too.